With the next two presentations, we changed the topic a bit. The first one is about strengthening foundations with steel micropiles and will be performed by Alexandre Pinto. So Alexandre Pinto is an invited professor at the Instituto Superior Técnico in the Technical University of Lisbon. He's also the technical manager of the JETSJ Geotechnics, Geotechnical and Structural Engineering Consultancy Company. He has more than 30 years of experience on both consultancy and teaching. So, Alexandre, you can start as soon as you are ready.
Thank you, Professor Eduardo, and thank you for the opportunity to be here to do this presentation. So, first of all, congratulations to Professor Eduardo Cavaco and Professor Eduardo Júlio for this the publication and also for this webinar. For me, it's a pleasure to be here speaking about this topic, strengthening foundations with steel micropiles. This is the index of my presentation. I will start with a short introduction regarding this subject. I would say that micropiling is already consecrated as a common and efficient solution for foundation strengthening. You have more solutions, but when you are talking about the strengthening of structures, special structures, for instance, in Europe and Portugal, nowadays is the more common solution. It has been developed since the last 70 years. Originally by Dr. Engineer Fernando Lisi. He invented the well-known root piles that later that solution was developed, and nowadays you have the micropiles that we use and that we know. Especially we have assist to an increase on the resistance of the steel. You have a better steel than some years ago. And also on the bearing capacity, the way that you can transmit higher loads to the ground without big deformations, because this is a key issue. We can have a high load on micropiles, but you should not forget that you should control the settlements of the structure that we are doing, where we are doing the reinforcement of its original foundations. This book is very well known. It's from Professor Fernando Lisi, The Static Restoration of Monuments, and some concepts of Professor Fernando Lisi we still use, some concepts, some approaches. That picture that you can see on your right-hand side is an important picture, because at that time they did not use caps that we use nowadays. You use reinforced concrete caps in general, where you have the cap of the micropile, and we tied those reinforced concrete elements to the original foundation. With Professor Lisi, they didn't do that. They used the micropiles also as a structural reinforcement element, like a nail. They nail the structure with the micropile, and the micropile goes down to the ground in order to transmit the load to the competent ground. Nowadays, we have also improvements regarding the size of the drilling equipment. So we are able to do this kind of works in very complicated conditions, very narrow spaces, very low headroom. And all of this is a development that we have been assisted in last years, and allows us to put loads, high loads in small spaces. So this is what the technology is bringing to us. So we use also segments of tubes, because if you are operating under a low headroom, you cannot use big length tubes. You must use tubes with 1 meter, 2 meters of length segments that you assemble the segments when you are doing the drill. So you can do a micropile with 20 or 30 meters depth inside the space with 1 meter large and 2 meters of headroom, 220 meters of headroom. So this nowadays is possible, which is a big advantage comparing with the solutions of Professor Fernando Lisi. Basics, when to adopt this method, wide range of scenarios, okay? You have the possibility to put a small machine and to put micropiles with the length that you need in every spaces nowadays. You don't need very large spaces, you don't need big headroom. You can do this everywhere. Regarding the available spaces, also regarding the geological conditions, because nowadays you can drill the micropiles in very soft ground. Sometimes you need to use casings, temporary casings or permanent casings. Sometimes you can change. Now I'm here, and today I'm speaking about the rotary micropiles. You do a drill with rotary, and you put the tube, the steel tube, inside the hole that you drill. But you can so use self-drilling micropiles. If you have soft soils, you can use self-drilling micropiles, because this will be the easiest way to perform your micropile. Materials and systems, still hollow tubes, as I already explained. Segments, they are segments, because if you have a condition of headroom, you must use small segments. You have a free length and a bond length. This is like a ground anchor. So the free length is where you don't want to transmit the load to the ground, because the ground is soft, because you are close to another construction. You can have some restraints that induces you to put the bond length. The bond length is where you develop the shaft resistance and where you transmit the load to the ground, okay? Sometimes you can use, in a tube, you can put a rebar inside the tube, and you can protect the rebar in order to eliminate the slip of the rebar, like a ground anchor. And you can induce the load transmission only through the bond length. The injection techniques, they are also, I would say, perhaps the major reason for this development, because nowadays you use injection techniques that are able to increase the bearing capacity of the micropile. And I will point out the double packer and the non-return valves we call manchette valves. This is a solution that was developed, as far as I know, mainly in France with the team of Professor Bustamante, where you can control the valves that you are opening, that you are injecting. You can control the pressure. We start with small pressures, and a bigger consumption of cement slurry, and you increase the pressure. And what you are expecting is that when you increase the pressure, you have a reduction on the consumption of the cement slurry. So P, pressure times volume, should be constant if you have a confined stratum. Is why you should do the bonding length in the better geological conditions that you can find in your site. So this is one of the reasons why you can nowadays put more load on the micropiles, because you improve a lot the injection, the way you build the bonding length, the way you transmit the load to the ground. Equipments, I have already explained to you. You have nowadays very small equipments, as you can see here. This is a small machine that can operate in a low headroom in a very narrow space. Okay, the power pack you can see here is where is the engine. So they have two members, so they can have with this a small equipment size. Stakeholders' roles and qualifications. I go very quickly in this point. The owner should know the impact on the structure, and not only on the structure, but also on the architectural solution of the building. Special because when you are doing these works, you must have the building free at the level where you are operating, and sometimes you have to rebuild the finishes of the building. And sometimes you have to change a little bit the architecture of the building close to the columns where you are underpinning where you are reinforcing the foundations. Quality control, quality assurance, the owner should be aware of this. And if the owner is not an engineer, is the most common situation, the owner should engage some staff, a company that can assist the owner and regarding the decisions about this kind of works. Service life and durability, of course, should be also present on the owner mind. The designer of this kind of solutions should have at least expertise on both structural and geotechnical engineering. You don't have a border here. There is not a border between the structural behavior and the geotechnical behavior. This is an interaction between soil and structure problems. So it's important that you have expertise on both structural and geotechnical engineering. The contractor, of course, should have expertise on geotechnical engineering works, mainly on small diameter drilling and slurry grouting. So should be a specialized contractor on micropiles, on ground anchors, on this kind of works where you have to do a small drill, and you have to put a bar or a tube inside, and mainly you have to do a very good injection, because one critical issue is the bonding length, the way you transmit the load by shaft resistance to the ground. The user should have awareness of the strengthening foundation solutions and management of the design live loads. This is important. Why? Because sometimes the buildings, they change the occupation. For instance, you have a building that was built for a residential occupation, and later it will shift to office occupation. The live loads will change. And if the live loads will change, it's better that you understand that if the first design was okay, was an economical design, sometimes you don't have space to accommodate the increase of loads. Sometimes another example. Sometimes you want to build an extra floor on your structure. You should not forget the foundations. Okay, of course you should reinforce the building to be able to accommodate an extra or one or two extra floors. But please check if the foundations are able also to accommodate the extra load. Design. Regarding the design, the assessment of existing conditions is very important. This is a soil structure interaction problem. So you must look for the ground, to the geological, hydrogeological, and geotechnical conditions, but you should look also for the structure, the existing structure and foundations to be strength. You must look the headroom, the access. You must take in consideration the corrosion of sacrificial thickness concept. Sometimes you have an aggressive environment in the ground, or not only in the ground, in the atmosphere. So all of those things you must consider at the assessment of the existing conditions. Sometimes you must reinforce the structure before you do the reinforcement of the foundations, because you must prepare the structure to be drilled and to put the micropiles crossing the original foundations. Service life should be compatible with structure service life. Of course, you should have a compatibility between both, including future changes in environmental and climatic changes, as this is nowadays a very important topic. For instance, changes on the groundwater level. If you have changes on the groundwater level, you must be aware of that. That could have implications on the design of your steel micropiles, as well as I have already stated, the future loading scenarios. Reliability requirements, design loads and durability, as I have already explained, codes and standards and other relevant references. You have several codes, several documentation regarding micropiles, not only in Europe. In Europe, the Eurocode 7, it's not very driven to micropiles, it's more for piles. Okay, we hope that you can have an upgrade an upgrade about that very soon. You can use also the approach of ground anchors because micropile, if is accommodating tension loads, it will work basically as a ground anchor works. And we have in Europe the aero norm for micropiles. Okay, this aero norm for micropiles is here. Aero norm 14199. It's just concerning the execution of micropiles. So what is missing is a design code like Aero Code 7, more dedicated to micropiles also. But I think in the future you can have it. In the United States, the FEHWA, they have the micropile design and construction guidelines and micropile design and construction reference manual. Here in Europe, at least in Portugal, we use a lot the Bustamante method. This method was developed by Michel Bustamante and Monsieur Dois. So it is a method that we use a lot in Portugal and I think in other countries in Europe. Design assumptions is very important to have a good estimation of the soil slurry lateral friction resistance, estimated if possible using static load test results. The Bustamante method has abacus where they have those relations, okay? For each kind of ground, the values of soil slurry lateral friction. And the Bustamante method is supported by the static load tests. Design procedure. Regarding the bearing capacity of the ground, the key issue is the shaft resistant design. We use bearing capacity design according to Bustamante and Dois method. You have here the expression. So you put a safety factor, a global safety factor. This is the method from 1985. Now we can use this according to partial safety factors of Aero Code 7 for sure. And you put a global safety factor plus the load, the service load, and you divide by an alpha. This is an expansion coefficient times the phi angle. The phi angle is the drilling diameter times the KS. The KS is the bond the lateral friction that you can develop between the ground and the cement slurry bulb. So this is a key issue. The KS is a key issue. You should have a good value that is realistic according to the geological and geotechnical scenario. The design resistance. The design resistance use the Aero Code 3 procedure, and sometimes you have to check buckling, okay? Because sometimes when you do underpinning, when you excavate below the original foundation, the micropile should be designed as a column, as a structural column, because you don't have ground around the micropile to confine the micropile. The other situation is when you have a very soft soil and drain shear strength lesser than 15 or 10 kilopascal. On those conditions, you should also check the buckling, the resistance, the structural resistance against buckling. Supporting documents, detailed design drawings and specification, as well main construction methods and stages, okay? At the underpinning works is mandatory. I would say that you should use always monitoring, but if you are going to underpin the original foundations, it's mandatory that you have a good monitoring solution, a good monitor of the structure that you are going to strengthen the foundations. Execution is very important to have preparatory works, access to the drilling points and working platforms. System trials, I will point out only the load tests in this kind of solutions. Execution procedure, we drill. After we drill, you put the steel tube inside the drill. You do a primary cement slurry filling from the bottom to the top. You do a secondary bond length grouting with pressure just at the bond lengthening. And after we fill inside of the steel tube inner space with cement slurry. The finishing, you have the reinforced concrete caps, as you can see in this picture. This is the underpinning of a building in Lisbon with 10 upper floors. And also you must tight in these conditions, you must tight the underpinning, the reinforced concrete cap against the original foundations, in this case, against the column. because you have already demolished in this picture the original foundation. Quality control, steel and slurry cement quality, you must check. This is the cement that is around the tube. This is not the bonding length, okay? This is the area where you put only the filling bottom up cement without pressure. And also before the intervention, sometimes it's important to do a static load test. This is a arrangement according to the ISTM suggestions. We use this also in other countries. Quality control during intervention, monitoring, cement slurry, dosage and components, homogeneity, resistance, and density. This is very important because cement slurry will be a key element when you transfer the load from the steel tube to the ground, because this transfers mechanism, the cement slurry is a key issue. Quality control after intervention, monitoring. Sometimes you have to keep the monitoring after you do the reinforcement of our foundations to check if everything is according to our design assumptions. And monitoring and maintenance is the same. Monitoring check both structural performance as well as the foundation solution efficiency. Maintenance, we should be aware the possibility to strengthen the solution due to the live load changes in the future. Other solutions, as you can see here, you can do the micropiles with an inclination. It's better to accommodate, for instance, horizontal loads due to the wind, due to the seismic loads. Post-intervention documentations as built drawings, records of the main execution issues. This is very important because in the future, you never know. The building is a live structure. You never know in the future if you don't have to do another intervention, okay? So you must record all of this important relevant information to assist, to help the future colleagues that will do the future works in the same building. As final remarks to conclude, I conclude with the same statement that I put at the beginning. Micropiling is already consecrated as very efficient solution for foundation strengthening. What you see here in this picture is our case study number 1. This is a very old building in Lisbon with more than 300 years, with Masonic structure, and the owner decided to build one basement, and we use micropiles, as you can see here, with reinforced concrete caps that were demolished after. We built the new columns and we connect the new columns to the original columns, and after we demolish these caps and we cut the micropiles, of course. Small and versatile equipments and segmental steel hollow tubes allow to work in narrow spaces with low headroom. You can see here, this is our case study 2. This is at Braga, is the north of Portugal, is the theater, the Circus Theater, is a very well known, and it was necessary to build a new auditorium, underground auditorium, and to keep the original auditorium at the top level. So you can see here, this machine is working, is doing the micropiles drilling in a very low headroom. And higher axial high service loads, mobilizing small deformations are becoming common. What you can see here is also the case study 2. You have 2 underpinning solution, the columns, isolated columns, okay, and the walls, okay. When you have a column, you have a single cap. You put those lower caps. They are only to prevent buckling, to reduce the buckling length, okay, and they are connected horizontally one to the others and also to this wall. So you have a beam to underpin the walls, and you have a isolated cap to underpin the isolated columns. And it's all that I have to tell you. Sorry, I overpass a little bit my time, but thank you for your orientation, and of course I will be available for any questions. Thank you.
Thank you very much for your clear presentation. So we have time for five minutes for questions. So I don't see questions on the Q&A button, but I see someone here on the audience that it seems that want to make you a question. I'm going to allow Nitsoa to directly put the question to you. Okay.
Okay.
So Nitsoa, you are allowed You are allowed to put your question to Alexandre if you want.
Oh, thank you very much. Yes, I think this is a very interesting presentation. So I just want to ask, in terms of the temporary stability of the building when you have removed the soil, did you sort of provide a way in terms of providing literal stability during construction? How did you take into account of that?
Are you talking about the case study? The case study, for instance, case study number 1.
Yes, the case study.
I call this one, for instance.
Yeah.
Okay. What we do in these circumstances, in these situations, you have to analyze if the structure is prepared for this. Okay. And sometimes we have to strengthen the structure, at least the base of the structure where you are going to do this underpinning solution. You have to analyze if the structure is okay. If it is not okay, you have to strengthen. As you can see here, you can see those steel beams here. You have beams in each side. With this, we tie the structure, and sometimes not only this we tie, but you put more beams to increase the horizontal stiffness of the structure. Okay, the structure should be prepared for those works. And here, what you can see in this picture is not very common, because in general, when we do this excavation, it's very important that sometimes you have to put here some bracements of the micropiles, because when you look to this picture, you have a feeling that from the horizontal point of view, something is missing. Okay. So we take this picture in the key day, okay, the D days, okay. So of course it's very important. They are already here. As you can see here, they have already here the beams, the foundation beams, and those micropiles, they are not they are not still braced by those beams, okay. But anyway, we design those micropiles for a buckling length that is the depth of this excavation. But in this situation, my suggestion is you should brace the micropiles at the base when you finish the excavation, even if it is a temporary bracing, okay? Because in this case, if you have in Portugal, this is in Portugal, in Lisbon, to have a seismic load during this excavation, the probability is very, 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 very low. But you can have wind, okay? You can have horizontal loads. And this could be an issue, okay? Could be an issue, because we design those micropiles only for vertical loads. If you have horizontal loads, you have to brace it, and sometimes you have to build also inclined micropiles. This is an issue, because if you go to the theater, here, you can see here, all of those caps, they are connected with horizontal steel profiles. All of this, of course, is temporary, and they are connected to the wall. It's very important that you stiff to horizontal movements.
Yeah.
Because if you have horizontal movements, you have second order effects, bending moments, and those tubes are very slender. They cannot accommodate high bending moments.
Okay, thank you very much.
You're welcome.
Okay, Alexandre, thank you once again for the detailed answer to this question.